Hello and welcome to our session. Today we'll be talking about delivering maximum returns with energy efficiency upgrades. My name is James Hill, Assistant Manager with DESA, and I'll talk to a series of communication tools. And my colleague, Dr. Riccardo Paolini, Senior Lecturer from the University of New South Wales, will talk to the simulation of energy efficiency upgrades in commercial buildings. You can download the slides from the resource library, and you also can put questions in the chat as we progress through our presentation. I'll now hand over to Dr. Paolini.
Thank you very much, James, and good afternoon, everyone. And so first, we thank the department for supporting this project, which is about the analysis of 12 buildings all over Australia that we consider as exemplar building to consider the opportunity for energy efficiency upgrades. And we're focusing mostly on residential buildings, predominantly commercial, but also including something which is not commercial. The precedent to this work is a low carbon living CRC guide on retrofits of commercial buildings, which focus mostly on upgrades of the mechanical services fundamentally. So considering that starting point, we moved into considering also building envelope upgrades and other opportunities. The objectives of this project are to consider mid-sized buildings predominantly with some good energy retrofit potential, and trying to spot the low-hanging fruits, considering both building fabric, as I said earlier, and building services. And part of the project is also a guide on different types of HVAC systems. The purpose of all of this is to display case studies that might be helpful to use if you're a building owner or a facility manager in deciding, making some early stage decision. So before even contacting a consultant, you wanna take a look at what the options are. And as I said, we considered 12 buildings from New South Wales to Victoria, Western Australia, Queensland, and we included three office buildings, one childcare, which is not NABERS rated, of course, 2 hotels, an aged care facility, a community center, a cool center, namely a heatwave shelter. This is something really new. It's the only one in Australia, but it was particularly interesting, a library, a restaurant, and a retail. All of those buildings were built between 1959 and 2010, so we didn't include buildings that were extremely new, but all of them had some potential for energy retrofits. Some of them already are including incorporating new technologies and improving their performance. How did we do that? So first of all, we got in touch with property and facility managers, and unfortunately, because of the COVID-19 pandemic, so the inspections of these buildings were somewhat limited, and we relied on that information to perform building performance simulations to assess retrofit scenarios in the current climate, namely with the currently available weather data and climate change projections with RCP 4.5, so an intermediate scenario provided by CSIRO for the year 2030. So as I said earlier, we received building documentation and information concerning occupancy, the set points for heating and cooling, and utility bills. Although the purpose of our work was not to conduct calibrated simulations, but to use these buildings as a starting point, namely as case studies. So because a calibrated simulation would require measurements for at least 1 year with detailed sensors and metering. So it was beyond the scope of our project. So results. So we had some buildings that had a starting point with high site energy use before the retrofit, and we could, with all these strategies that we considered, we could improve the energy performance reducing the site energy with savings ranging between 24 and 63%, and in all cases improving the neighbors rating. Of course, here we are talking about simulations and not about meter data. Here we are showing the star bands in 2 digits, just to say if it's a comfortable 5 or it's a comfortable 4. Here I'm showing a couple of these buildings. So the first one, it's an office building in Victoria. This building in particular has implemented a lot of energy retrofit interventions, from LED to installing reflective roofing to heat extraction from the heating. But here we are considering its pre-retrofit status, as it was, the building was in 2007. Because with simulations, we can compare different interventions, even if in the reality they were performed all at the same time or in subsequent years, and therefore you cannot compare them in different climate conditions that you have year after year. So as the building already had some reflective roofing, reflective roof coating, the cooling demand was not excessively high, so it was namely evenly distributed heating and cooling energy loads. The very first thing we did for all of these buildings is to analyze the gains and losses to identify energy retrofits opportunities. In other words, this means the first thing, you are trying to assess where the money is getting out of your pockets if you own the building or you are the facility manager. So understanding what are your liabilities. If the money is flowing out of your pockets through the roof, if the money is flowing out of your pockets through the windows because you have a lot of solar heat gains during the summer season, this is causing very high cooling energy consumption, or whether it's appliances or something else. So the very first thing is to try to identify what is the cause. And this changes, obviously, building by building, case by case, and climate by climate. But the important bit here is following a method to identify what's the cause, which you cannot do only with energy bills. So the two things go hand in hand. And then we implemented incremental retrofits, so one after the other, considering an improvement in lighting, changing the windows to double glazed ones, improving automation and controls using ceiling fans, and also night ventilation and roof insulation and wall insulation as well. So, however, all of this follows a path so that here I highlighted. So initially, the building had a very high electricity demand for lighting. And in fact, one of the first things they did in the actual building was replacing lighting when they started the retrofit journey. In this also, by changing lighting, reduces the cooling energy needs because it reduces the heat dissipation. And then with dimmable controls and the light controls, we also improved drastically the electricity needs. Then moving to windows retrofits with double glazing, and then after that with automation and controls to use energy only when you need it and where you need it. An interesting part is that of ceiling fans, because with air movement, you can have a set point temperature for cooling higher by 3 degrees, namely you can have it at 26 or 27 degrees and still feel thermal comfort. And then with night ventilation for the summer period and heat recovery ventilation for the winter period, we can drastically reduce the heating and cooling. We focus on these two bits because these are the most where we can save more money and more kilowatt hours. and then moving forward only in the end towards roof insulation and wall insulation. So first we started with the low-hanging fruits, things that do not disrupt the building use, are not excessively expensive, and you can implement progressively. And here are the results and how much the site energy is reduced so drastically. Then, however, so we focused a lot on reducing the cooling energy needs. And why? Because in the future, those will increase drastically because of global climate change. So even if the balance in the long run will be unaltered, there will be a shift. So a lot of mixed climates or heating-dominated climates will become more and more cooling-dominated climates. So we need to, even if a building is energy efficient, we need to tune it to the new climate context, even though it didn't move. A second example is for retail in Queensland. Again, a very high cooling demand, unsurprisingly. And by reducing lighting, we reduce heat dissipation from the lighting appliances. And then with reflecting roofing, we reduce a lot the cooling load, and then moving progressively with more substantial interventions. The important bit here is that working together with your neighbor assessors and with your consultants, you can identify the low-hanging fruits, and you can also identify retrofit options that avoid building disruption, that allow you to continue using the building without disrupting business. And likewise, in this case, it's already cooling-dominated climate, and the cooling energy needs will increase further by 2030. To wrap up the gist of our study, we assessed stage interventions to increase progressively the energy efficiency of existing buildings. One of the key hurdles that we face, and you all face, is that, of course, building documentation is often insufficient. You buy a property and you don't know exactly what's inside the walls. And this is a problem we should all work together on. Still, even though LEDs have become popular, there are a lot of buildings without them, and there are a lot of opportunities in that space. And even if building fabric interventions normally are perceived as expensive, there are some interventions that are cheap and deliver quick savings before you move towards touching and replacing the mechanical services. So you can reduce the size of the new appliances and the new mechanical services. So you don't need to, first you reduce the load, and then you work on more efficient mechanical services. As I said earlier, cooling energy needs are going to increase more and more, and therefore we need to future-proof our buildings. And final consideration is that appliances were not covered in this project because they were out of the scope. They are not. We were focusing on building services, so appliances are not considered a part of the structure of the building, if you like. However, they still represent a significant opportunity for savings, and then can reduce metered energy. And thank you, and I pass the word back to James.
Thank you, Riccardo. A really fascinating presentation. So, as you've seen, energy efficiency is truly a wonderful thing. Successfully implemented, it can reduce cost, reduce energy efficiency, and reduce emissions. So, in recognition of this, governments, both state and federal, have funded and have a range of policies and programs which target energy efficiency. So following delivery of the really high quality research that Riccardo and the team from the University of New South Wales have delivered, there's now a wealth of high quality simulated energy efficiency opportunities across a range of building types that Riccardo discussed. In response to this, the Commonwealth Department for which I work for, the Department of Industry, Science, Energy, Environment and Resources, engaged a communications firm known as Boxing Clever to really deliver some tailored communication products, delivering learnings for both commercial buildings disclosure and NABERS assessors in a plain English manner to provide tools for energy efficiency upgrades for building owners and managers. So the way they did this is the Boxing Clever team first consulted with several NABERS assessors, really to help understand the gaps and the barriers that their assessors and their clients were recognised in regard to energy efficiency opportunities. In response to this, the BC team then produced a range of fact sheets based on the university research, distilling some of those key messages into research products that really were tailored to focus on the value proposition of energy efficiency upgrades, and really, looking at that value proposition to the building owners and managers. As part of the process, the BC team then circled back to the NABERS assessors, really to confirm those messages they captured were fit for purpose for their intended use. And as a result, the team have produced a range of fact sheets for the categories of which Riccardo mentioned, particularly offices, hotels and aged cares. And I'm going to walk you through some of those now. Moving along, So I mentioned the offices. I'll touch on that first. The Boxing Clever team produced 3 fact sheets for offices across Brisbane, Sydney, and in Wagga. Effectively, these locations were chosen because they're broadly representative of the offices in this space, and also representative of different climate zones. As you can see from the Queensland office example on the board, the cooling load was the major baseline load for this office. The uni modelling found that there was a potential for 48% energy savings associated with energy efficiency upgrades in this office space, and that equates to a potential increase in NABERS ratings from 4.5 to 6 stars in this example. So I'll walk you now through some of the most impactful energy efficiency upgrades for that Queensland office. Firstly, the installation of energy efficient light sources with daylight link controls, that provided 16% energy savings. Then on top of that, the addition of building automation controls and management systems potentially provided a further 15% of savings. Looking to that, then adding the ceiling fans provided an additional 8% of energy savings. And on top of that, the provision of night ventilation provided an additional 9%. So cumulatively, these upgrades resulted in that 48% of energy savings from the base case. I'll now walk through from offices to an example in residential aged care. So the BC team produced 1 fact sheet based on the uni modelling for a residential aged care facility in Canberra. The fact sheet was designed to be broadly representative of a facility in this location. Unsurprisingly, in Canberra, particularly this time of year, heating was found to be a major base load for the modelled Canberra facility, and you can see that on the slide. For this example, the university, for the full suite of upgrades modelled, found that energy savings of up to 88% were possible, and I'll walk you through those now. So, again, the energy efficiency upgrades are listed. The upgrade of energy efficiency lights resulted in a 3% energy saving. Next down, the adding of roof insulation. This is where things get really exciting. So that was found to provide an additional 30% of energy savings. Then adding on top of that, if the interventions were also to add energy efficiency windows and wall insulation, that could provide an additional 35% energy savings. And then add to the mix an air-to-water heat pump or even a ground source heat pump, there's another potential 20% of energy savings in that upgrade. So cumulatively, you can see these upgrades really add up to that rather large 88% potential total energy savings from the base case. Now I'll moving across again to an example of a hotel. So the Boxing Clever team produced fact sheets for hotels in both Perth and Sydney. Again, as previously, these fact sheets are broadly representative of those types of structures in these locations. In Perth, as you can see, cooling was the major base load for this Perth hotel. And again, using the full suite of modelling energy efficiency upgrades, there was potential for a 65% energy saving for this Perth hotel, and that equated from an increase in potential NABERS rating from around 3 stars to around 4.5 stars. So, where did those whether those potential opportunities happen. So the external shading devices in the Perth Hotel actually provided up to 20% of the base energy savings, and adding automated control and management systems provided an additional 15% of energy savings. Adding the night ventilation, you're looking at an additional 12% for energy savings for that intervention. And then providing a ground source heat pump rounded it out with a further 15% of energy savings. So again, cumulatively, you can see the message coming through here. Cumulatively, these upgrades potentially added up to 75% savings for the base case as the model scenario. So selected fact sheets will become available from the NABERS website in the near future around the Boxing Clever communications products, and the University of New South Wales building simulation reports will become available from the University of New South Wales website as well. And I guess we both do. I encourage you to keep an eye out for these, and when they become available, please look at them, interrogate them, and make your own judgment on the utility of the tools for your own buildings or the buildings you manage on behalf of yourself or your clients. Look, I really trust these resources will communicate both the value of NABERS and encourage and promote opportunities for energy efficiency and energy savings from those energy efficiency interventions. So I'm now going to walk through what a call to action might look like through a potential case study. And so in this situation, congratulations, you're a building owner and you've just received your first NABERS rating for your office in Queensland. So now, as undertaking that activity, now that you've collected all the baseline operational data for your building, you can plan to improve it over the coming years. Please ask your assessor to identify areas for improvement and associated cost savings so that you can plan both short-term cost-effective projects and also plan for, in your directory, for the longer-term cost-intensive type of interventions that might be required to get you to your ultimate end. Ask for a fact sheet to help you target some of those most relevant opportunities, and noting that we just talked through some of those in different locations previously. In our Queensland office, you've seen that the most likely opportunities might be around upgrades to windows, ventilation, and automated systems. As part of the package, you as owners, you might also wish to seek additional background information. Look, please look for colleagues, also look potentially to undertake energy performance audits so you can really understand your building nature and develop your own sustainability goals. And I guess in developing those goals for your directory, think about your budget constraints and in a way set interim targets to your long-term goals. So by that I mean if your 10-year goal might be to transition from a 4.5 to a 6-star, then plan out those short-term iterations that may help you get there. Don't forget to quantify those potential savings and include them in your project budget. I would trust it will be helpful to communicate these savings to your stakeholders, to bring them along the journey with you, to help them and potentially you improve your understanding and appreciation of the value of the NABERS rating, both in terms of sustainability, value and amenity to those that use the built structures. So with that, I'm going to thank you for your attention and engagement, and I'm noting, just looking at my screen, that we have a couple of questions. So please, I encourage you to keep submitting questions, and I will read through those that we've got now. Riccardo, so bear with me, bring it closer while I don't have my glasses on, the sign of old age. So I'm looking now. So first question is, what are the building fabric upgrades that are the cheapest and easiest to deliver? Question mark. What do you suggest are the relatively cheap building fabric interventions? So, Riccardo, can I ask you that question? So, two-part there. What are the building fabric upgrades that are cheapest and easiest to deliver? And what would you suggest as interventions?
I start from the suggestion. So the first suggestion is, and thank you for the question. So the first suggestion is to look into where the biggest energy losses occur. So, but there are some interventions, especially for cooling, that are relatively cheap. So, for instance, if you have a building which is in a cooling dominated climate and you're spending a lot of site energy in cooling, then if the rooftop is poorly insulated, applying a solar reflective coating will reduce a lot the solar heat gains. If the roof is already hyper insulated, let's say you have a 20 centimeter of insulation. This is not the case for most buildings, but just to say, if you already have a lot of insulation in the rooftop, then the reflective roofing will not make a huge difference on the individual building. If you have all reflective roofing across the city, then it will reduce the direct temperature, and you will have indirect benefits. But that's another story. Likewise, applying, installing more efficient automation and control systems for solar control devices. So from simple internal roller blinds to exterior shading devices that are, of course, most efficient in terms of reducing solar heat gains. That's also relatively cheap. But however, all of this depends very much on the building and the context. Of course, if you're talking about improving roof insulation or improving wall insulation, that's more expensive, obviously. And the idea here is that first you tackle the cheapest things, so you start saving money and you build the capital for investments and reducing other liabilities.
I really liked your example in the presentation, Riccardo, of where the money's falling out of your pocket. That surely speaks to all of us.
Yeah, building owners and facility managers see dollars. I see kilowatt hours per square meter, because that's you don't need to actualize it for inflation, but it's the same thing in the end.
Thank you, Riccardo. I've got another question on it. It's very similar, but it's maybe about the sources. So the person asked, where can we find information about the cheap means of improving the building fabric that you mentioned in the conclusion? So what resources would you suggest are available for owners and assessors to find these sort of cheap, options?
Well, first, have a look at the opportunities that you will see in our reports, but also talk to your assessor. And a lot of whether something is cheap or not depends a lot on very site-specific and project-specific and context-specific factors. For instance, if you're talking about a single office building or just above 1,000 square meters or so, just so that you need to disclose its performance. Maybe you don't have enough leverage to bargain on new windows, and especially if you're asking for something that is slightly different for what's commonly available. If instead you're talking about retrofitting a portfolio of buildings, that's a completely different story. What becomes, these things best. In the reports you will find some ingredients, but then you, together with your assessor and with your consultant, will be in the best position to decide what recipe to go for. And it's fundamentally similar to the situation where you are having an issue and you go to your GP. You wouldn't take any pill or go straight to surgery just based on a symptom without taking some blood tests and maybe an X-ray or something like that and consulting a GP. So likewise for buildings. So if the pressure on the meter is high, first you go for some testing and understanding what it is, and then based on that you move forward towards saving. In many cases, the interventions on the building envelope were not the first ones. In many buildings, we recommended first going for lighting and then automations and controls. So first, you're making sure you don't have issues in terms of controls and having higher than the desired set point in spending money unnecessarily. So this is where usually you have the biggest savings.
Thank you, Riccardo. Again, I like the analogy of the building doctor. I think we've hit a nerve here. There's another. I've got another question around the cost. And so the person asking the question is asked, how can I undertake the analysis of energy gains losses to identify retrofit opportunities? And really, in brackets, how do I know where the money is falling out of my pocket as the building owner?
Good question. Thanks for asking it. So when you get the energy bill doesn't tell you from where the money is flowing out. To do so, the only way is to, well, there are two ways. An expensive way and very sophisticated is to install sensors anywhere. Not viable. We just do it in research projects. The other way is to run a building performance simulation, similar to what's done in this project. So with calculations performed by a consultant, you can identify and have an understanding of the situation for your building. So the first thing is to conduct a survey of the building, provide the building documentation, and in providing the building documentation, that's the most demanding task for you as a building owner or facility manager, because depending on the status of the building documentation, it might take you more or less time. And that is super important, however, because of, like for anything, for any calculation, garbage in, garbage out. So if the information that you provide the consultant with is insufficient, the figures that can come up are unreliable. However, simulations are the only thing that help you to understand whether a parameter is having a large effect or a small effect. What if I increase the roof insulation? Is it worth doing it? With a simulation, you can do it. On the physical building, you cannot just try and see what happens, and often it's impossible to, even if you've done one intervention, say this year you replace and you put LED lights, and the following year you want to do something else, but then the weather conditions are different year by year. It's difficult to make comparisons. The only way is to have a simulation. The first simulation doesn't need to be perfect. Even if it's quick and dirty, at least it can give you a reasonable idea, as long as the input data are robust.
Yeah.
Again, it doesn't need to be perfect. There's a lot of variability, but at least it can give you a fairly good idea to start making some considerations, and then you might decide whether to proceed with more sophisticated analysis. So.
Thank you. No, look, I heard it mentioned this morning, it comes back to that age-old adage, you can't manage what you can't measure. So, no, thank you, Riccardo, a very good assumption. Now, I see we've still got questions, so let's keep talking until someone tells us to stop. But I'm just noticing, I think I'll go here. The question is, would solar PV be better value for money than energy efficiency upgrades if the building has an adequate roof?
Not actually. So the first thing we recommend is to go first for energy efficiency, and then after that go for renewables, because at some point you run out of rooftop. So that's the basic thing we see in most cases. So if the building has no inefficient controls, so you have the aircon running at 20 degrees or 22 degrees in rooms that are empty where nobody's there because an occupancy sensor is faulty, and some of the buildings that we analyzed in this project and in other projects had some of these issues that the facility manager addressed. So you run out of rooftop at some point.
Yeah, but would you do both? Like, it's not a one or...
You do both. Do both, but the first thing is, you try to reduce the liabilities, the money that's flowing out of your pockets, and then you go for HVAC upgrades, and then for renewables on site. Also bearing in mind that when you have critical events like heat wave or cold snap, etc., the efficiency of many machines is impaired. So the electricity yield of of photovoltaics decreases with increasing temperature. Likewise, the COP or ER of air conditioning decreases with, so the efficiency of air conditioning decreases with increasing temperature. If you have a building with heat pumps and then it's a particularly cold season, at some point they will spend a lot of energy just for defrosting. Yeah. So the first thing is fix the leaks first, or not stay in a glass box during heat wave, and then from there. Once you reduce the load, you remove the load from your shoulders. You can travel more efficiently with a leaner engine and also with powered by renewables.
With a Ferrari engine. Look, I feel like I'm getting off quite late. There's two more questions here, and I think one of them we can do really quickly. So one of the questions is, where can I find the reports? So
soon we will release the website and also upload the reports, and they will be shared also by neighbors.
Excellent. And there's a question around the ACT aged care question. So the question reads, I'm interested in the ACT aged care fact sheet, wondering how to retrofit wall insulation into existing walls, ? Also, what are the paybacks for changing windows to energy efficiency windows? This would appear to be a huge cost for RACF, which I assume is a return on investment. Yeah.
Indeed. So indeed, some of these things are a substantial cost in cooling-dominated climates, such as that in ACT. You're looking at returns for residential or aged care, which is very similar, of 7-8 years. However, you're also providing with better comfort. In the case of aged care facilities, you're also providing a better acoustic environment and many other co-benefits. And also you can look into deductions to return of your investment faster.
Yeah, and that was probably one of the better examples in Canberra, given such an extreme in climate, to see those. They were quite big numbers that were simulated through.
But indeed, a lot depends on the age of the building, and also we provided a context, but then the financial modeling has to be done specifically, and also because if we did something last year when we ran most of these analyses. Now with the supply chain, it would have been completely different. So it's something to discuss together with your consultant and your accountant, even an early conversation, but at least you get an idea for your specific case.
And bring data into that equation, bring as much information as you can in. I think we possibly have time for another question. I'm not sure if this is out of our expertise, definitely out of my expertise. The person's asking, does a refrigerant in a chiller impact its energy efficiency rating? We're contemplating upgrading and in an attempt to reach net zero, but we don't know if it's worth it. Does that touch on your? Maybe we.
No, we didn't touch on that. We didn't touch on that.
Yeah. No, sorry to
However, yes, it does impact. So shortly, in brief, yes. It's not included in our study, changing the refrigerant type. But yes, of course, it does impact the performance.
Thank you. And we might have one last question, which has been around for a bit. The question is, how do we select buildings for these studies? Do you want to take that one?
Okay, so during COVID, it hasn't been so that easy because especially for office buildings, a lot of facility managers we got in touch with were changing jobs. So first we got in touch with Facility Management Australia, with NABERS, with ASPEC, and also with other facility managers in our contacts. And then we were looking at buildings that had some either a history of energy retrofits, and then we decided where to model the building in its history, or we considered buildings that had a lot of opportunity.
Yeah. Excellent. Thank you.
Thank you.
I've just been informed we actually have 5 minutes to go. So again, all these have fallen to your side, and thank you for your experts' guidance in this. So our last question is a bit of a trajectory question, and it's from the position of the person asking it obviously has a building and they want to go the extra mile. So the question is, I have a building and it's been on a NABERS journey for a number of years, progressing from a 2.5 to a 5-star.
Congratulations.
Yeah, no, it is good. So number one, thumbs up to you, to that owner. Now that all the low-hanging fruit is gone, what can I do to progress from a 5-star to a 5.5-star? So this is I guess the question of once the easy is done, how do you progress there? Again, hoping to keep as most of that money in our pocket that we can.
Get more sustainable users. This sounds like a joke, but actually it's one of the factors that especially when a building is very efficient, the impact of users' behaviors will be huge. So the first thing is if it's an office building and you have the opportunity to invest in working together with the users, that is great because it's where you have a lot of uncertainty. And then the other thing is trying to have some metering and some measurements on site to assess if everything is running as it should be. As mentioned earlier, some of those buildings had some malfunction here and there in terms of metering, in terms of controls, in terms of set points, aircon run during an occupied period, so there was not much efficiency in set max. So a good building management system and tuning this. And the final thing, but this is still, which is important, is in addition to having sustainable users, is giving people the opportunity to self-regulate a little bit more. So moving towards one thermal comfort approach that should fit all,
yes,
as it was in open office environments, to personal thermal comfort. This is very much different here. So having a baseline temperature and giving people, especially if it's office buildings or something similar, the opportunity to adapt. So whenever you have the chance, that is also because you will not have all the people there at the same time.
And can I reflect too? Also, part of bringing people along the journey with you, as your neighbour's journey, it's not just a building manager or an owner journey. It's also a tenant journey. It's as much as possible engage the group, so then people are more willing to understand the reasons for their thermal comfort within a zone because it has greater impact. I think there's a really
and also if it's a lease, depending on how you build the contract, that's a different story, because if people don't see the energy bills in their rent, they tend to use more energy.
Yeah. So start that dialogue. Riccardo, there's probably time for one more question. Are you up to it? I haven't worn your voice out. Excellent. So the question is, for an office tower, is there a technological limit to achieving 6-star neighbours without changing the temperature bandwidth? That might be, I'm not sure, that might be a question that we might have to refer to others actually.
To be honest, it depends on the building. Broadly, without changing the temperature bandwidth, it depends very much on how you can achieve free cooling. And if you can achieve night purging and free cooling. But again, depends very much on the specific. Night ventilation can help a good deal, and depends a lot on the thermal mass if it's exposed or not in the building. So in some cases it's possible.
Yeah. Okay.
But of course, the big chunk there will be the lifts. So that's not easy, to be honest.
Look, thank you so much. Thank you, audience, for listening to our talk. Thank you, Riccardo, for your excellent presentation.